Okay, back again for Chapter 2. Chapter 2 for Math for Electronics, we're looking now at powers of 10. So we introduced some of those concepts of powers of 10 in Chapter 1. Now we're going to go out a little farther and see how we apply and use these powers of 10 as tools for handling our numbers. So you can see there are quite a few chapters or sections in Chapter 2 that covers everything from conversion of numbers to powers of 10 form, handling the operations, addition, subtraction, multiplication, division, looking at that term reciprocals that we mentioned in the last chapter, and then squares and square roots. So our objectives then are converting numbers to powers of 10, expressing scientific, and later we will also be doing engineering notation, adding, subtracting, multiplying, and dividing, and some use of the calculator, solving problems with complex denominators, and using the reciprocals and square roots and squaring numbers. So in Rule 2.1, again, we're going to look at converting some multiples of 10 to powers of 10 form and count the number of zeros. Term we're going to get used to using a lot is the exponent. The answer is 10 raised to that power. Getting used to then the powers of 10 form, knowing that the number of zeros that we have in the decimal number relates directly to the number that we use in the exponent. So 10 to the 6th means 6 zeros. 10 to the 4th means 4 zeros. The thing that we have to start getting used to is something called engineering notation or the metrics later. We use the values of multiples of 3 primarily in engineering and electronics. So 10 to the 3rd and 10 to the 6th become very important exponents and powers of 10. We can look at it also in terms of the reciprocals or the values that are less than 1. Again, 10 to the 0 is 1, so that's just 1. 10 to the minus 3rd, we've got 3 zeros in the denominator. 10 to the minus 6, we've got 6 zeros in the denominator. So we have this form, the decimal form, the fractional form, the expanded form, and then over here we see our exponential form. Okay, these all become handy tools when we start dealing with exponents and powers of 10 in different operations. Division it becomes very, very handy. Multiplication. The exponents tells us how many times 10 is used as a factor. So we can see here 4 tens tells us that we've got 4 to the 10th or 10,000 as a factored number. Rule 2.2, converting from powers of 10 to the decimal, write the 1 digit and follow with as many zeros as indicated. Sometimes reading these rules may not make a lot of sense to you until you've gone through and worked through the process. Then go back and read the rules and they will make more sense to you. So read through each one of these 2.2, 2.3, and 2.4 when handling fractions, powers of 10, to make sure you understand what is being said in those rules. If the number is 1, the exponent is 0. 10 to the 0 equals 1. So if we look at other values here, 10 to the minus 3, that means that the 1,000, in this case, goes into the denominator and immediately becomes a 1,000 value. So we can express 10 to the minus 3 this way, or this way. They all mean 1,000th. The same thing for 1/10,000. 10 to the minus 4, 1 over 10,000, 0,001, or 1/10,000th. You have to be able to move along this continuum from one to the other sometimes to solve these problems. So if we look at relationships in decimal, decimal fraction, and powers of 10, these are all ways of handling these decimals in the numerator so that when we get ready to do the operations, it makes it easier for us to solve a problem. Rule 2.5, converting from a decimal fraction to powers of 10, count the number of zeros in the denominator. Rule 2.6, in converting from a decimal number to powers of 10, count how far the digit is located to the right of the decimal point. So again, we can see here, now we're going in the opposite direction. 2 places gives us 1/100th, which is 2 places here, 10 squared, or 10 to the minus 2. Notice when we moved 10 squared out of the denominator and into the numerator, we merely changed the sign. So the same thing applies for the other 2 examples. Rule 2.7, to multiply numbers in powers of 10 form, we add the exponents. So in this case, since the value itself, the base is 10 and 10, it remains the same, we can simplify this by adding 6 and minus 2 together to get 10 to the 4th. If we look at this in terms of a fraction or a decimal, we can see the same thing applies. Multiplying 1/100th times 1,000,000 gives us 10 to the 4th. Okay, so there's lots of different ways to handling it. This gets a little cumbersome, so handling the exponents is definitely a shortcut and makes things a lot easier. Okay, another example, 10 to the minus 4th times 10 to the 3rd. We combine the exponents, bingo, we're done, 10 to the minus 1. If I convert this into the numerator, if I were to move this actually out of the denominator form, we again would change the sign. Division, to divide numbers in powers of 10 form, subtract the denominator exponents. So in this case, we have 10 to the mth power, 10 to the nth power. We would merely move the value in the denominator into the numerator, subtract n from m. Okay, put some hard values here instead of these literals. We have 5 minus 2 equals 3. Okay, and then we can use the more cumbersome form here, 100,000 divided by 100. You could very easily just say, okay, well, I'm going to cancel that zeros, and I'm going to cancel those zeros. I'm left with 1,000 over 1,000, which gives me 10 to the 3rd. To divide numbers in powers of 10 form, subtract the denominator exponent. Again, we've got the same sort of relationship here. Okay, makes it much, much easier to handle if we can do it using the exponents than these cumbersome big numbers here. It might seem easier to put these numbers into the calculator, and there's nothing wrong with it, but once you learn the calculator exponential mode, this becomes a lot easier. Okay, to divide numbers in powers of 10, subtract the denominator. So lots of examples here for you to look at. I suggest you sit down, work through them. On some of these, work through them by hand. If you want to enter them into the calculator to help you understand how the order of operation is, please do that. Okay, more examples here. Okay, next we'll look at combined multiplication and division in powers of 10 form. So it gets a little more complicated. So we'll come back to that and finish up chapter 2.